So we're going to hear from Dave first, and then I guess we'll have sort of 5 minutes comfort break while Kira gets set up, and then we'll hear from Kira. And then after that, please stick around for a coffee and a chat. So I'll introduce Dave. Dave Bottrill, who is a freelance web developer, and he's going to, well, you can see the title of the talk on the screen there. He's going to be talking about writing Python packages in Rust. And Dave, it says here you're one of our regular Chalk attendees. You're not just one of our regulars. Have you made it to every event?
I have pretty much made it to almost every event,
so,
as far as I know.
You're like a founder member of Chalk Connect, so that's since whenever it was, November 23, I think it was, the first one. So yeah, thank you for that.
No
Dave has been coding for over 40 years, more than 10 of those using Python. He's an information junkie who loves to learn and is seeing the world one conference at a time. He's passionate about using technology to empower everyone. So there you go, give you Dave.
Hello. Thank you very much. Okay, quick show of hands, unfortunately. You have to excuse me for this, but who has ever actually done any coding at all? Any coding? So that's looking like, that's everyone. Okay, that's very good. Who has used Python in any shape or form? Okay, that's not too bad. How many people have used Rust? Yeah, actually a few more in Rust. So that's actually really good, because basically I was trying to pitch this a little bit towards people who are not always perhaps completely technical. They're going to be like, got a little bit of knowledge of tech, but not actually work in the industry as a programmer. So yeah, so you're going to have to excuse me, all tech people going, there isn't any code in here. There is very little actual code. It's more a case of just trying to get people, get the understanding. So that's what we're really I'm trying to achieve here. So who am I? As we've just heard, I'm David Bottrill. I'm a freelance developer, full stack developer, web developer. If you've got any questions about the talk, please don't ask me now, because I'll completely freeze up and say something stupid. So send me an email if you've got any questions, or just talk to me over a coffee. And yeah, it's just one of those sort of things where we'll just move on quickly. Right, so goals of the talk. Provide a general overview of the terminology and technology. Because unfortunately, technology is stuck with an awful lot of very difficult jargon. I think one of the problems that I find with most technology is the fact that the same word turns up in every technology I've ever used. The worst culprit for that, and I can see Ethan's smiling away there because he's had exactly the same problem. The word component. If I had $1 for every time a new technology uses components, I would be stuffed, because we overuse these same words again and again. So therefore, that's why we're going to find that it sounds really strange as me talking what seems to be semantics, but it is just one of those things where I'm just going to quickly go over these different words, different usage, and we'll just hopefully take away something from this. And so that's why we're talking about technology and terminology. What is a Python extension? Python extension is, at its core, it's simply what looks to be Python. You're using it as you would normal Python. Actually turns out using a completely different computer language, something completely different. You know, if you were just using Python, that would be just a regular Python package. You're not. You're actually using completely different language, but it doesn't look like it to you. You know, if anyone's used any of the packages, you know, you'll quite often find that you find that things like pandas, things like this, you think you're using Python because it's a nice Python package. You can import it, use all the functionality. It's not Python, but it's great. So anyway, that is why we're talking about Python extensions. We're talking about the differences between Python and Rust. It is a little bit of like, I always think of it as surgical equipment versus, which is Rust, as compared to Swiss Army knife, which is Python. Python does lots of things moderately well, quite well, but not fabulously, whereas Rust, very much your surgical scalpel. It's brilliant, but you would hopefully not give a scalpel to a newbie and say, here, off you go, because most junior doctors, I think, might run away screaming if they just were expected to start performing surgery straight off the bat. And this is a little bit of the learning curve of Python as compared to Rust. Rust is wonderful, but you do need to know what you're doing to start with, at least. So, talking of all that terminology being used multiple times, what is a package? A package in Python and a package in Rust. Thankfully, it's about the same sort of thing. It's really just a group of code all put together, normally in a way that you can download off the internet. Great, job done. So then we're talking about pip packages and cargo crates. Okay, that's, again, those are the names that they're all packages, but they're just, pip is for what Python use, crates are what Rust use. So, okay, that's what we're trying to do with that. Then we're actually just talking about virtual environments. And you're like, more terminology? Why are we talking more terminology? The reason why we're talking about virtual environments is the fact that, as I will talk about a little bit later, encapsulation. Sometimes you want to be able to have it so that you can have more than one application running on your program, on your machine at the same time. But the problem is those two different programs can use totally different versions of the same package, and those two packages conflict with each other. So you'll find that they will break each other if they're trying to use the wrong version. So you go, I know, I'll use a virtual environment, and each one will then have its own little fiefdom, its own little encapsulation, its own little universe it can then exist in that doesn't conflict with others. So, okay, that's what a virtual environment is, very quickly. Talking about data types, although you'll probably quite laugh at how much I'm talking about data types, because data types is quite a big subject. So I'm not really going to go into it too much. I'm really just going to say, here's a data type. It's a way that your program, whether it's in Rust or whether it's in Python, it's a way that it internally recognizes whether you've just said a word or whether you've just said a number. So it's really just a case of, do I want to store a number? Do I want to store a word? For a computer, it's very, very different the way it stores those two things, which is why we have what's called different types. So it's just a way of describing to the machine how you want it to store that information. And then finally, we'll actually do a little bit of actual code, tiny amount. It's going to be, what can you do in a computer, CLI, command line interface. Basically you have to type words into the machine and it goes, oh, okay, that's worked, or no, that hasn't worked. Great. So, what is a Python extension? In a bit more detail now. Enables libraries and extra functionality to be written in other computer languages. Why would we use other languages for Python? Well, honestly, performance. Swiss Army knife is absolutely fabulous, but not at doing things quickly. It's an all-rounder, but you wouldn't expect them to do things very, very quickly, because it doesn't. It doesn't. So therefore, that's why we use other languages. Memory safety. Are you thinking, what's memory safety? Memory safety is when you've got that application on your computer, it sits there, it runs every day, but if you ever look at how much memory it's using, you'll quite often find it's doing the exact same thing, and one day it's using 500K. Great. Next day it's using 700K. Day after that, 2 meg. And you're thinking, Am I doing that much more with this program? You're not. What's happening is you've actually got a memory leak. It means that at the end of the day, whoever's written that code has managed to grab a chunk of memory when they were doing some work, and then when they finished using it, they left it there. So the next day it comes along and does exactly the same operation and suddenly adds just that little bit more memory allocation, and it keeps on doing that, which is why sometimes when you've got really old computer software, you sometimes have to shut down a machine every so often and then bring it back up again because it just keeps on chewing through memory. This is not a good way to run things. It costs money if you're using cloud services. It'll just cost you money. So we want languages, and both Python and Rust are brilliant at memory safety. So that sounds wonderful. Also, low-level access. What's low-level access? Low-level access is dealing with different devices. Some languages are really good at writing, and being able to create other software, hardware, and you've actually got to talk to that hardware. You can't just simply, high-level languages like Python, you can use it to do that, but you've got to use special versions of Python to do that. This isn't what we're talking about here. We're just talking about, I've got a piece of software I need to talk to, or a piece of hardware, and I don't want to have to write the specialist software to do that. So therefore, I'll do it in a different language like Rust. It does it all for me. Excuse me. Right, so an extension looks like standard Python package, as we were saying. An example would be the lovely word import. Import is the Python code to just simply say, there's an external package and I want you to bring it into the machine so I can actually use that piece of external functionality. You know, I can extend the Python language with this really cool feature that I hadn't written myself, but somebody else did on the internet, and I'm bringing it down. And the fact that that's written in Python or it's written in Rust, the machine doesn't care. And the great thing is, through the magic of technology, we can do that, and the developer using it doesn't care, doesn't have to. It just works. So, differences between Python and Rust. There's a reason why there's a part 1 and a part 2 for this, because it's a lot. But the real difference is the fact that Python uses an interpreter, Rust is a compiler. It simply means, as you know, we normally talk about interpreters and we think of a person stood next to you. You know, you're talking to someone Russian who doesn't speak any English, so you say what you want to that person, and then the lovely translator translates it to you, to the other person you're talking to in Russian. That's all great. Problem is with that is the fact that it's really slow having a conversation. Unlike and that's the way that Python does it. Every time you run a program, it goes through every single line, converts it to a form that the machine understands, and once it's finished running, that's it. It forgets it all. Next time you do that, you run it again, it does that all over again. So you're like, yeah, that's not the speediest way of doing this. The better way of doing it is compiling. Compiling means a translator sits there and goes through everything you're going to say to that lovely Russian person, puts it all into like a book, and then you've got that. You don't need that translator anymore. They can just simply be there, and they can just you can hand it to the Russian person and say, this is what I want. Obviously, you want to know what you want before you actually do it. You know, it's a bit hard to have a far-ranging conversation like that. But if you've got instructions, then this is wonderful. Good way of doing it. That's the way a interpreter works. That's the way Rust works as a compiler. And that's what we are basically, that's why we're using Rust, because Rust gives you that performance because you don't have to go through every single line every single time. Right. And yeah, So we got statically typed and dynamically typed, as we were saying about the different ways of encoding information. The point is with this is the fact that, again, with Python, Python just does it itself. It figures out, it looks at what you're putting into it. If it's a word, it goes, okay, that's a string. If it's a number, it goes, okay, that's a number. And it does that. It does it all by itself. Rust, you can do that to a degree, but mostly, no. You've actually got to tell the compiler what you want, every type and every piece of information. So it does basically mean that you end up putting a lot more work into writing your code, and also the, I think it'd be fair to say, the level of understanding you have to have of the language is higher. So all good stuff. Then we can also talk about data hiding and encapsulation. Now, we've actually touched on that when I was talking about virtual environments, that whole idea of you can't have conflicts, and that's the way programs actually work. They have different pieces of code, and as much as when you first start writing code, you don't want to have it where two pieces of code can't talk to each other. When you're writing larger software, having the idea that one piece of code can hear what another piece of code is saying, that becomes a really bad thing, because it's very easy to overwrite and just introduce bugs into your system, because you've got two variables called hello world, and they're both overwriting each other because you hadn't realized that the scope, they're in each other's scope. So therefore, encapsulation stops that from happening. Now, again, differences between Python and Rust. Python is very open about this. It says, hey, you want to have a variable? Cool, go for it. And I'm not really going to hide it. It's up to you to understand when to use this, which is why we actually use, if you ever see something with an underscore, a variable name and an underscore, that basically means don't use this. This is being used already by the software. So please don't use this. But the problem is if somebody goes in and they're not really paying attention, they're just new to it. They don't realize, don't use code. It's got an underscore to start with. They do it, bad things start happening. So the good thing is that the way that Rust works out this problem is it says, fine, everything is private. You've got to tell the software straight away, this is actually public. Otherwise, it says, no, it's all private. Right. Error handling. Two different languages, one compiled, one interpreted. They are really different in the way they deal with problems. Because Python's a pretty much object-oriented language. It means basically that it uses exceptions. It's a class in itself. It's great. Everything's a class. We can work with that. Again, the problem is you've then got Rust. Rust is not an object-oriented language. It's a functional programming language. So no objects for you, or at least no classes anyway. Objects, yes. Classes, no. So yeah, it's got its own way of dealing with this. And in fact, it uses monads, which sound really cool and really complicated. And honestly, they are. So I won't go into that too much, because it's one of those sort of things where they talk about monads, and they're called monads, but in fact, it's not actually using the mathematical conception of monads. It's actually a pattern which we use, which is just a conception of how a monad works. It's not actually how an actual monad works. Anyway, I'm going to stop saying the word monad and say differences between modules. They both use modules. Python, Rust, both use modules. The way that they understand modules are different. Python, you only have one way to do a module. It's a file. It's just simply, it's your code in a file, hello world.py, that's a module. Great. But in Rust, things aren't quite that simple. Yes, you can have a module like that, but most of the time there's all sorts of different nice ways of describing them, which are a little bit more complicated, which is why I didn't go into it too much, because there's about 5 different, is it 5 different ways, Ethan, you can define a module in Rust, or is it more? I know of 5. Yeah, well, this is it, but either way, you have a lot of granularity. You can do a lot of very clever, very subtle things, whereas Python's a bit more, here's a module, that's it. you get what you see. So, what is a package? Again, we've got different ways that you interpret it as a package, but as we said before, it really is just mostly a thing that contains files in directories or folders, depending on what operating system you're using, and that's really it. Although I've got lots of things here as to how it's all structured and everything else, at the end of the day, they're just a collection of files and directories that are downloaded, and this is the way you extend your language. You download it, install it, great, you have your new package. And they both actually use .toml files for their configuration, because a package actually needs to be configured. So with, I think it's Pi project, I think it is. Yeah, I'm just trying to remember some of the Pi projects, because they've just changed how Python. It's one of the things that I sort of say here is the fact that you can actually, they keep changing how Python does packages, but either way, it's a configuration file, and it tells the different package managers how to actually structure your code. Okay, what is a pip package? It is really just a thing from PyPI, which is the repository online. You can download it. It's all good. And although you can put various different things in there, you can just basically create a pip package and put the functionality in there. I won't go into this too much, because I'm talking about how the directory site packages directory gets used, but I don't think we really need to go into too much detail here. So anyway, virtual environments, I think I said before, it's really just a case of we've got the different ways we want to encapsulate it. This is how we encapsulate it. And then, as I said about different types, how does the different ways of memory management between the 2 different languages? Python uses garbage collection, which basically just works on the principle of, I've stopped using this particular allocation of memory. If everyone stops looking at it, then it goes away. The garbage collection says, okay, nobody's referencing this anymore, go away, and it disappears. Great. Rust does something a bit cleverer. It actually says, you know what, I'm going to look at this, and as soon as it looks like people stop using it, it's gone. I just remove it. It never existed. So, which is why you end up having quite a lot more to think about when you're actually dealing with Rust ownership and borrowing, because if you're not careful, it'll forget a piece of information, and you're like going, I didn't want you to forget that, please don't do that. So yeah, a little bit more thought involved. Right, getting started with Rust extensions, the actual code. Well, not really code, it's just typing a few words into a command line. But we are going to be using a pip package downloaded off the internet called Maturin. And Maturin is, again, what can only be described as a Swiss Army knife of pip packages, because what it does is it actually contains within it the Pi03 crate. So it's got a package with another package inside it, but they're different language packages. So, simply going to just read this out to you. Sorry, I probably should have actually typed this in on the computer and actually shown it to you, but I thought whenever people do live coding, it always goes wrong. So I thought I don't fancy doing that. So hope you don't mind. But yeah, so all you do is create your virtual environment, which is just simply, as you can see there with dir A, it says Python 3 -m venv env, which simply creates a virtual environment called env. Then, once you've got that, then you need to do start it. Because if you can create a virtual environment, but unless you've started it, it doesn't do anything. So then you use the word source, env /bin/activate, starts it up. Great. We now have our very own virtual environment. It's running. Then I can do a pip install. So I can pip install Maturin. So it will sit there, and as long as you've got an internet connection, or you can actually have it where, of course, you've downloaded it before, and both pip and crate, or cargo, sorry, will actually go, I've seen that before. I've cached that. So even if you haven't actually got an internet connection at the time, you can actually download it, or at least install it. So nice bit of coding there, I think. Then just create a directory in dear old D. So make directory, which is a real mouthful, I apologize. Test Rust extension for Python. I think I was clearly channeling Java development there when I came up with that one, sorry about that. But then it's a case of change the directory into that directory, and then you can just literally type the word Maturin in it, and it then does a whole bunch of really clever stuff, including asking you, do you want to actually create a Pi03 extension? Because you can do other extensions as well. Maturin's quite clever. It'll do other ways of doing it as well, but we're using Pi03, so that's what we do. And then once you've done that, then you can just do Maturin develop, and you now have your very own Rust extension in your current virtual environment. And as long as you have that virtual environment running, you can just go into command line, type Python, Python 3, it'll start up, and then you can just do import test Rust extension for Python, and it'll work. So you get all that functionality. And as I said, this all works straight out the box. It does give you a very rubbish piece of functionality, I have to admit. The functionality is it takes two integer numbers, and then produces a result as a string. So the word 10, or the word 10 plus 10 you've said, it'll then put 20 in inverted commas. So it'll still be 2.0, well, 2.0, with the 69s around it, and there you are, So thank you for your time. And that's me done.